Biomolecules. 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 Chapter 14. Biomolecules. It has harmonious and synchronous process of chemical reaction in our body which leads to life. Our living system grows, sustains, and reproduces itself. The most amazing living thing about living system is that it is composed of non-living atoms and molecules. The pursuit of knowledge of what goes on chemically within a living system falls into the domain of biochemistry. The living system are made up of various complex biomolecules like carbohydrate, protein, nucleic acids, and lipids. Protein and carbohydrate are essential constituent of our food. These biomolecules interact with each other and constitute into molecular logic of life process. In addition, some simple molecules like vitamins and mineral salts also play an important role in function of organism. Structures and functions of some of these biomolecules are discussed in this unit. Carbohydrates. Carbohydrates are primarily produced by plant and form a very high group of naturally occurring organic compounds. Some common examples of carbohydrate are cane sugar, glucose, starch. These are the examples of carbohydrate. It is most of them of general formula CxH2OY and were considered as hydrates of carbon, from where the name carbohydrate was derived. For example, the molecular formula of glucose C6H12O6 fit in this general formula C6H2O6. But all the compound which fits in this formula may not be classified as carbohydrate. For example, acetic acid CH3CHCHO CH3COOH fits into this formula C2H2O whole 2, but it is not a carbohydrate. Similarly, ramenose C6H12O5 is a carbohydrate but does not fit in this formula definition. A large number of their reactions have shown that they must contain a specific functional group. Chemically, the carbohydrate may be defined as optically active polyhydroxyaldehyde or ketone, or the compound which produce such units on hydrolysis. Some of the carbohydrates which are sweet in taste, also known as sugar. Some carbohydrates which are sweet in taste are known as sugar. The most common sugars used in our home is known as sucrose, whereas sugar present in milk is known as lactose. Carbohydrate also known as saccharides. Greek word of saccharon means sugar. Classification of carbohydrates. Carbohydrates are classified on the basis of their behavior on hydrolysis. They have been broadly classified into three groups: monosaccharides, a carbohydrate that cannot be hydrolyzed further to give simple unit of polyhydroxyaldehyde or ketone is known as monosaccharide. About 20 monosaccharides are known to be in the nature. 20 monosaccharides are known to be in the some of examples are glucose, fructose, ribose. These are monosaccharides. Oligosaccharides. Carbohydrate that yield 2 to 10 monosaccharides unit on hydrolysis is known as oligosaccharides. They are further classified into disaccharides, trisaccharides, tetrasaccharides, etc. depending upon the number of monosaccharides they provide on hydrolysis. Among these, the most commons are disaccharides. Two monosaccharides unit obtained on hydrolysis of a disaccharides may be same or different. For example, one molecule of sucrose on hydrolysis gives one molecule of glucose and one molecule of fructose, whereas maltose gives two molecules of glucose only. Polysaccharides, carbohydrate which yield a large Member of monosaccharide unit on hydrolysis are called polysaccharides. Some examples of polysaccharides are starch, cellulose, glycogen, gums, etc. These are these are these are the polysaccharides and are also known as non-sugars. The carbohydrate may be defined. The carbohydrate may also be classified as either reducing or non-reducing sugars. All those carbohydrates which reduce failing solutions or tolerant reagent are referred as reducing a sugar. What is reducing sugar? The sugar या carbohydrate which reduce failing solution and tolerance reagent are referred as reducing sugar. This is important. All monosaccharide, whether aldose or ketose, are reducing sugar. Monosaccharides are further classified on the basis of number of carbon atom and functional group present in them. If the monosaccharide contains an aldehyde group, it is known as an aldose, and if contains keto group, it is known as ketose. Number of carbon atom constituting the monosaccharide is also introduced in the name as is evident from the example given in table 14.1. Carbon 3 triose, and for the general term triose, and for aldehyde aldotriose, and for ketone it is ketotriose. So like this for carbon atom: tetrose, aldotetrose, ketotetrose; pentose, aldopentose, ketopentose; hexo hexopentose, no, hexose, aldohexose, ketohexose; heptose, aldoheptose, ketoheptose; glucose. Glucose occurs freely in nature as well as in combined form. Freely in nature as well as combined form. It is present in sweet fruits and honey. Ripe grains contains glucose in large amount. Preparation of glucose from sugar. From cane sugar. If sucrose is boiled with dilute acid means HCl or H2SO4 in alcoholic solution, glucose and fructose are obtained in equal amount. C12H22O11 plus H2O in presence of acid. In presence of acid, C6H12O6 and C6H12O6. This is glucose and this is fructose. From starch. Commercially, glucose is obtained on hydrolysis of starch by boiling it with dilute H2SO at 393 Kelvin under pressure. C6H10O5 whole N plus N H2O. H plus 393 to 3 atm and C6H12O6 glucose. Structure of glucose. Glucose is an aldohexose and is also known as dextrose. It is the monomer of many larger carbohydrates such as starch, cellulose. It is probably the most abundant organic compound. On Earth. It was assigned the structure given below on the basis of evidence. 1. Its molecular formula is C6H12O12. C6H12O6. This is the structure of glucose. C6H12O6, CHO, CHOH whole 4, CH2OH. In the presence of HI and heating, a straight chain of 6 carbon atom forms. These are very important. Glucose reacts with hydroxyamine to form an oxime and adds a molecule of hydrogen cyanide to give cyanohydrin. These reactions confirms the presence of carbonyl group in glucose. C6H12O6 on the reaction with NH2OH, it forms CH double bond NOH, and after CHOOH HCN with the reaction of HCN CHCNOH, glucose get oxidized to 6 carbon carboxylic acid, glucogonic acid. On reaction with a mild oxidizing agent like bromine water, this indicates that the carbonyl group is present as an aldehyde group. Br2 water CH, C6H12O6 on reaction with bromine water, CHO is converted into carboxylic acid, which is known as glucogonic acid. Acetylation of glucose with acetic anhydride gives glucose pentaacetate, which confirms the presence of 5OH group. Since it exists as a stable compound, 5OH groups should be attached to different carbon atoms. C6H12 on reaction with acetic anhydride gives this compound, which shows that it contains 4, 5, 5, 5, 5OH groups. On